Hi folks, and welcome back to the channel. Continue along the lines of beginner electronics. One of the best ways to develop skills is by doing. This is especially true for soldering. And one of the best ways to learn to solder is to build relatively easy and inexpensive kits. Now this Elenco K37/RS-400, I'm not sure which way they want to name it. This kit is a perfect example. It uses only passive components and electromechanical components that are resistant to thermal damage. It's relatively simple, and it only costs about 15 bucks on Amazon, so it's pretty inexpensive too. And once you've built it, you've got a useful addition to your electronics kit. These resistance substitution boxes are very handy from time to time, and it's good to have one or two of them on hand. So in this video, we're going to build this up. I'm also thinking I'm going to make a small modification to it, which I think will make it a little bit more pleasant tool to use once it's complete. In addition, we'll be using all the tools from our beginner's toolkit that we've been going over in another playlist to build and test it. Let's have a look and see what's in the box. I think I've got my modification items are in here too. So we've got a circuit board, some solder, which I'm unlikely to use because it's lead-free solder. I don't get along well with lead-free solder. We got the box, and we got all the parts. And these here, these two little banana sockets are what my modification is all about. Now normally this would should have these two leads with alligator clips on them, just coming up through this hole here. And you can see it's pretty tight, and you know just a couple alligator clips on the end. It's not a lot of play there. There's not a lot of room. The length is very short. So what I wanted to do was mount these in here at the standard 19mm spacing. And then we could just plug in proper length clips with alligator clips on the end of them anytime we want, or plug it directly into a digital multimeter, or whatever we want to do. We have a little bit more versatility if we do it that way. And here are the resistors we're going to be using, the switches, and some of the mechanical hardware like knobs and screws. So let's get started. Let's do one more in real time here. Let's go into R2. Now, what I like to do when I put them in is I like to get all the color bands the same direction. It just looks a little bit more professional when you look at it, and makes it a bit easier to read the values if you have to go back and read them again, because they're all facing the same direction. Form the leads, put the resistor in, and solder it in place. Again, we'll start off with the more difficult one. Require a little bit more time to warm up. Put the solder in place, let it flow, and then the next one. Now every time you do one of these joints, make sure that you're pushing the iron up against the component lead and the trace, and heat them both up at the same time. That's very important. Trim the leads, and we'll carry on. Now at this point, I'm just going to speed up the video until I get all these resistors in place, because they're all basically going to be the same, exactly the same process, nothing different. And once we get to something more interesting like switches, or once we finish this, we'll we'll come back and get into real time again. Now, what happens if you flub it and get too much solder onto the joint, or you make a bad joint where the solder is not properly adhering to the component or the trace? Well, that's what the solder sucker's for. So what you do then is you just heat up, melt the solder, and suck it out of the way. And either you'll be left with just enough, which in this case we are, or you can add a little bit more to complete the joint properly. And then you would just reheat the joint and apply a tad more solder like that. So that's it. We now have all the resistors in place. Hopefully I didn't get any of them in the wrong order. We'll find out when we go to test it. And now is to mount the switch, and it would be this switch here. Mount this in position. It looks like it can only go in one way, or that it doesn't matter. It can be a little bit tricky. So what I'm going to do with this is I'm just going to tack in one side first, like this. And make sure it's sitting properly. Come this way a little bit. Looks good. And then I'm going to solder in the other legs. A little bit tricky because the legs are pretty close together, but if you lay the iron down the side of the component like that and push it in towards the center of the hole, it should work out pretty well. That one's giving me a little bit of trouble there. Let's see what's going on. We'll try that again. Clean my tip. Yeah, that's much better. Okay, so now the switch is in place. Now, let's see what's next. Now they want us to wire what would have been the alligator clips, but we're not using those, we're using these. So we'll go ahead and we'll wire these in at this point. So that's sort of permanently now, we'll attach the top to the circuit board. It looks like the rotary switches will be mounted first at the top, and then the board will be put over them, and then the switches will be soldered in place. So let's put these wires in. I want this to cut about 1.5 inches. Let's say that's about that much. I think we're not going to use these wires. I'm going to use red wires to attach these and black wires because there's some jumpers that have to go on the back here. So I'm going to use the black wires for those. Oops. This is easier said than done. Much easier said than done. I'm going to actually, in this case, I'm going to go against my normal route. I'm going to bend the wire over. That'll help hold it in place while I get some solder on it. That's one done. Turn it off. In there and bend it over. Excess off. There, just to show you guys what I'm doing. Got the wire into the lug and bent over, hold it in place, and then we'll just solder it in. Perfect. Perfect. Now I guess we'll be mounting these switches. Yep, that's the next step. Well, these switches are identical. It doesn't matter where they go. Just going to put them into place, get them mounted up. I'm not going to tighten these completely yet because I'm going to have to rotate the switches a little bit to get them lined up to the circuit board. And then we will these down, get them lined up and put them into place. There we go. Beautiful. Now, let's start by tacking down one lead on each one. Here we go. Now just continue around. We don't solder these. These have to be connected via jumpers from here to here, according to the instructions. So we'll do those after we finish with all of these ones. So we'll just go around the switches, one contact by one. Look, the switches are fully soldered into place. Now all we have to do is make those connections from here to here. Another joint here, this one here. It's got a little space. Now it's a good joint, but it's not complete. So this could maybe fatigue over time. So I'm going to just touch it up a little bit here. There we go. Right, there we are. Now just measure out little bits of the black wire for the jumpers on the back. So we've got to go from this switch to here. And the other wire is going to be exactly the same length. Yeah, let's put this part of the instructions right here. So these jumper wires are going in. And that should complete the connectivity. Yeah, this is rated for 600 volts at 90 degrees C. That's very good wire for what purpose we're using it for. Anyway, let's strip these. A little bit, 1/8 of an inch off each end would be enough. And start at this side. I'm just going to insert it in like that, fold it back. That's soldered in place. Here we go. Now we'll get this end over to the wiper of the switch. That's what this lead here is. It's the wiper of the switch. Let's tin both. What I mean by tin is put a little bit of solder on both the wire and the terminal for the wiper. Then we just them next to each other and melt the solder. Make a good solid connection. And we'll do the same on the other side. Looks like I got just enough solder to get this job done. Again, we'll tin up both pieces to be connected. And make the connection. Perfect. Well, there it's electrically finished. So we'll come back in a minute and we'll do the final assembly and test it all out. Okay, let's get these nuts tightened down here on the switches. They don't have to be tightened up too much, just snug them down. Nothing's going to go anywhere. That's fine. Now we'll put this on here temporarily. So what we want to do first is align the knobs so that they're pointing the right way for the right number. So we'll just get our meter here. We'll put it onto ohms and put this over to the left hand side there and check the value that we get. So we're getting 216. So that's, oh, I guess that's pretty good. Okay, so we'll push that knob down there and then let's go down to 1,000, see what we get. Yeah, okay. So we'll run through the tests on that. Now we'll go over here to the right and see what we get here. 98.4K. I would imagine that is going to be the 100K resistor here. Let's line this switch up best we can and see if this goes to 220, 215. That's within the 5%. 68.3. Okay. Now let's go through the whole test. So what I'm going to do with this to make it a little bit easier, so I don't have to hold things, I'm going to get this cable here, plug it in, and then just attach that directly to the meter leads. Polarity doesn't matter here. We're talking about resistance, so we'll just do that as a matter of form, and we'll go through here. So we'll check out. This should be around about 10.5. That's just within the 10% or the 5%. That's well within 22. 47. That one's great. 99 point. That's good too. Yeah, they're all good so far. Yeah. Haven't made any mistakes so far. That's nice to see. 680.674, so it switches to a different range. 1.012, 2167, 3209, 4650. Now we're going to switch over to this side here. We'll go down to the lowest value and go up from there. 665. 10K is 9.73, 21.55, 32.7, 48.02, 68.3, 98.4 as we saw before, 215.4, 325, 476.7, 674, and 1.027 mega ohms. So we got all the resistors in the right place. They're all within tolerance, and everything seems to be working. So why don't we just screw the lid down, and we're all done. Need a fairly small Phillips screwdriver for this. Would the next one up be a better fit? Yeah, I think this one's a better fit actually. So we'll get these tightened down. Now don't over tighten them, just snug them in there so that things don't move around. It'd be very easy for these little screws to strip into the plastic. So just do them in until they seat nicely. You'll feel the resistance increase, and that's when you should stop. Right about there, just so things don't move. There, we're all finished. Nice. And not only did we get a lot of soldering practice, but we have now a nice little instrument to add to our collection of electronics tools. Well, thanks for joining me, guys. We'll see you in the next video. Bye-bye.